We'll start in a minute. We'll continue graphing quadratic functions using the transformations. We got to this one. Y equals negative 3x squared plus 18x minus 27. But I'm going to do that on a different piece of paper so that there's more room. Okay, let's get it into the vertex form. The vertex form is y equals a times the binomial x minus h squared plus k. And the ordered pair for the vertex, when it's in this form, is hk. Okay, to get this into vertex form, first we factor negative 3 out of the x squared term and the x term. But we leave the constant minus 27 outside of the factorization. And you can always check your work along the way by multiplying. Negative 3 times x squared minus 6x is negative 3x squared plus 18x. So we move to the next step. The next step is the adding zero step. Or the completing the square step. So now we're focusing on x squared minus 6x. And we want to add a number to that so that we get a perfect square trinomial. So somebody online, type in what number I should add and then subtract so that we get a perfect square trinomial. So someone online, anybody watching, we want to create a perfect square trinomial inside the parentheses. So what number should I add? Okay, we're going to add 9 and then subtract 9. This is referred to as adding 0. Plus 9 minus 9 is 0. We're adding 0 because we don't want to change the meaning or the value of the expression. We're just changing its form. Okay, the next step, we keep the perfect square trinomial inside the parentheses, x squared minus 6x plus 9. And then what goes on the outside of the parentheses? Okay, we already have a minus 27, but what else? Well, from the previous step, the fourth term in the parentheses is -9. So we multiply -3 times -9, which is positive 27. That means in this step, we're going to add 27. Okay, now we have, in the next step, we can write the vertex form, -3 times the binomial x minus 3 squared, and minus 27 plus 27 is 0. When the y-coordinate of the vertex is 0, we don't need to write plus 0. So the vertex is 3, 0. So you can write this as y equals -3 times x minus 3 squared without the plus 0. But it's something that you should remember if you want to find the vertex. Well, you have to realize we're adding 0 out here, so the y-coordinate of the vertex is 0. Okay, how many x-intercepts are there going to be? So a parabola either has 2 x-intercepts, 1 x-intercept, or no x-intercepts. Yeah, the vertex is also the x-intercept. Okay, so there's 1 x-intercept. Whenever there's only 1 x-intercept, it means that it's the vertex also. Okay, so we can at least start graphing this. So there's the vertex. It's the ordered pair 3, 0. But we should find a couple of other points at least. So how about if we find 5 points? I want to use my general approach. The x-coordinate of the vertex is 3, so I'm going to pick 5 x values, where 3 is the middle one, and then 2 smaller x values than 3 that I'll use are 2 and 1, and 2 bigger values, 4 and 5. So we already know 3, 0 is a point on the graph. So let's start with x equals 1. We have options. We can use the original standard form, y equals -3x squared plus 18x minus 27, to find the y-coordinate that goes with x equals 1. But we also have the vertex form. We are allowed to use either of those. Remember to think of those as formulas for finding y-coordinates whenever you pick an x-coordinate. So it looks like the easiest thing to do, at least it looks easy to me, is to use the vertex form. When x equals 1, y is equal to -3 times the quantity 1 minus 3 squared, or -3 times the number -2 squared. then remember the order of operations. Negative 2 squared is 4, so we have negative 3 times 4, or negative 12. So that's off the grid already. When x is 2, we'll get a point that's closer. So when x is 2, what's the y-coordinate? Okay, when x is 2, if we use the vertex form, the y-coordinate is negative 3 times the quantity 2 minus 3 squared, or negative 3 times negative 1 squared, which is negative 3 times positive 1, or negative 3. Okay, we can use symmetry to determine the y-coordinates that go with 4 and 5. The y-coordinate that goes with 4 is the same one that goes with 2. So when x is 4, the y-coordinate is negative 3. And also by symmetry, the y-coordinate that goes with x equals 5 is the same y-coordinate that goes with positive 1. So that should be negative 12. Okay, so we can plot a couple of those points. 2, negative 3. So this is a point on the graph. 2, negative 3. And also 4, negative 3. So we get our parabola. Okay, let's move on to the next sheet. Okay, we want to write this quadratic function in vertex form. Y equals negative 4x squared plus 16x minus 8. Okay, I'll give you a minute or two to work on that. See if you can find the vertex form. Find the x and y coordinates of the vertex. Find the ordered pairs for all of the intercepts. To get it into vertex form, factor negative 4 out of the x squared term and the x term. Or factor negative 4 out of the first two terms, so we're left with x squared minus 4x. But leave the minus 8 on the outside of the parentheses. Then add 0 on the inside of the parentheses while creating a perfect square trinomial. So we're just focusing on x squared minus 4x to create a perfect square trinomial. Take half of -4 and square that number. That gives us +4, but we write +4 and then -4 to maintain the balance or to maintain equality. And then in the next step, we keep the perfect square trinomial inside the parentheses, x squared minus 4x plus 4. And then on the outside of the parentheses, we're going to add -4 times -4. So together with the -8 that's already on the outside, we're going to add 16. And then the next step is the vertex form. -4 times the binomial x minus 2 squared plus 8. The vertex, the ordered pair for the vertex is x equals 2 and y equals 8. So we're reading the vertex from the vertex form to 8. Hey, the vertex 2, 8, that's above the x-axis. The parabola opens downward, so that means the parabola has to cross the x-axis twice or in 2 different places. So there are 2 x-intercepts. So one way to find the x-intercepts is replace y with 0 and then solve for x. So replace y with 0. So somebody on YouTube, why do we replace y with 0 in order to find the x-intercepts? There has to be a reason for that procedure. What's the reason? You can type it in one short sentence. We need one variable. That's, well, yeah, true, but why wouldn't I replace y with a different number? That would also give us one variable. If I replace y with 10, then I have just one variable. But why do we specifically replace y with 0 and then solve for x when we're trying to find the x-intercepts? So this is one of those little details that, if you remember, can save you a lot of grief when taking tests and quizzes. It's just a small detail, but it's a very important one, it turns out. So when we want to find the x-intercepts, why do we replace y with 0? and then solve for x. Okay, so 0 is an equation. Well, if I replace y with a different number besides 0, it's still an equation. Okay, this is a key point. It's a small detail, but a very important detail. When finding the x-intercepts, the reason that we replace y with 0 and then solve for x is because every x-intercept has a y-coordinate that's equal to 0. That's the reason. Every x-intercept has a y-coordinate equal to 0. In other words, every point on the x-axis is associated with an ordered pair, and the y-coordinate of that ordered pair on the x-axis is always 0. Okay, so replace y with 0. 0 equals negative 4x squared plus 16x minus 8. One thing we can do, since everything is divisible by negative 4, we can get rid of some of the clutter that's in the way if we divide every term on both sides of this quadratic equation by negative 4. So 0 divided by negative 4 is still 0. Negative 4x squared divided by negative 4 is x squared, plus 16x divided by negative 4 is minus 4x, and negative 8 divided by negative 4 is positive 2. So when we solve this, we'll use the quadratic formula. A is 1, B is negative 4, and C is 2. Okay, so we get x equals the negative of negative 4 plus and minus the square root of the number negative 4 squared minus 4 times 1 times 2. All divided by 2 times 1. Okay, so the negative of negative 4 is 4, and then plus and minus. So inside the square root, negative 4 squared is 16, minus 8 is 8. The square root of 8 is the square root of 4 times the square root of 2. The square root of 4 is 2, so we have 4 plus and minus 2 times the square root of 2 divided by 2. So I guess up here I'll write the x-intercepts since I took up all of that space. Remember, a point in the xy plane is associated with an ordered pair. An x-intercept is a point in the xy plane. When we simplify 4 plus and minus 2 times the square root of 2 over 2, one of those will just be 2 plus the square root of 2. The y-coordinate is 0 for that x-intercept. And the other x-intercept, the x-coordinate is 2 minus the square root of 2. And the y-coordinate is 0. So we might as well graph it. I'll get out a different piece of paper. So we're going to graph y equals negative 4x squared plus 16x minus 8. In vertex form, it's negative 4 times x minus 2 quantity squared plus 8. We found the x-intercepts. 2 plus the square root of 2 comma 0 and 2 minus the square root of 2 comma 0. Hey, let's identify the y-intercept while we're at it. Hey, what's the procedure for finding the y-intercept?
Replacing with x is 0.
Yeah, the procedure for finding the y-intercept is replace x with 0 and then do the arithmetic, and we get y equals negative 8. So why do we use that procedure for finding the y-intercept? So for finding the y-intercept, this time we replace x with 0. Hey, so somebody online, when we find the y-intercept, why do we replace x with 0? It's the same concept that we used when we were finding the x-intercepts. When we found the x-intercepts, we replaced y with 0 and solved for x. To find the y-intercept, we replace x with 0 and solve for y. Okay, so the reason, I'll give you the reason, I'll write it down. The reason that we replace x with 0 when we want to find the y-intercept is every y-intercept, remember the y-intercept is a point in the xy plane, and every point in the xy plane is associated with an ordered pair, meaning that it has an x coordinate and a y coordinate. So every y-intercept has an x coordinate of 0. So if the x coordinate is 0, then in the equation, I just replace every x with 0, and what I'm left with is the y coordinate of the y-intercept. Okay, so the y-intercept is the ordered pair 0, negative 8. Okay, those details, I keep saying, they're small details, but they're important. And all of those details add up. If you omit 2 or 3 of those in your memory, then you're headed towards disaster. Oh yeah, what's the vertex? I wrote it down on the other piece of paper, but so here's the vertex form. So the vertex is the ordered pair 2, 8. Okay, so I guess we can get a rough sketch of the graph. So the ordered pair 2, 8. One of the x-intercepts is the ordered pair 2 plus the square root of 2, comma 0. The square root of 2 is about 1.4142. So 2 plus 1.4142 is 3.4142. So right in here, 3.41. And then 2 minus the square root of 2 for the other x coordinate of the x-intercept is about 2 minus 1.4142. So that's about 0.59 or so. So it's right in here. So we get a skinny parabola that looks something like this. So this x-intercept is 2 plus the square root of 2, 0. And the other x-intercept, 2 minus the square root of 2, comma 0. Okay, so another thing to remember. So I'm going to stop assuming that you remember what I've told you. So write x-intercepts as ordered pairs. An ordered pair has both an x-coordinate and a y-coordinate. Well, y-intercepts are also ordered pairs, so write the y-intercept as an ordered pair. An ordered pair has both an x-coordinate and a y-coordinate. Okay, the next example. Y equals 2x squared plus 8x plus 4. Okay, we'll get it into vertex form first. So we factor 2 out of the first two terms. So factor 2 out of 2x squared plus 8x, we get 2 times x squared plus 4x. Leave some space for the adding 0 part, and then the plus 4 stays on the outside of the parentheses. Okay, the next step is the adding 0 step, or the completing the square step. So now we're focusing on x squared plus 4x. We want a perfect square trinomial. So we take 1/2 of the coefficient of x and square it. 1/2 of 4 is 2, 2 squared is 4. So 0 comes in the form plus 4 minus 4. Okay, in the next step, we're going to keep the perfect square trinomial inside the parentheses. So inside the parentheses, x squared plus 4x plus 4. We already have a plus 4 on the outside. And then going with that is what we get when we multiply 2 times negative 4. 2 times negative 4 is negative 8. So that means In this next step, we have to subtract 8 on the outside of the parentheses. Okay, the next step is the vertex form. So y equals 2 times. So what binomial do we square to get x squared plus 4x plus 4? On the outside of the parentheses, plus 4 minus 8 is minus 4. Okay, so yeah, online you're one step ahead of me. What's the binomial that we square? Yeah, so this binomial is x plus 2. So we have, this is the vertex form, y equals 2 times the quantity x plus 2 squared minus 4. So the vertex is a point in the xy plane, so it's an ordered pair that has an x coordinate and a y coordinate. The x coordinate is -2 and the y coordinate is -4. Hey, how many x-intercepts are there? There's more than that. Okay, the vertex is below the x-axis, right? The point whose coordinates are -2, -4, that's below the x-axis. And the parabola opens upward. So the parabola has to cross the x-axis in 2 places. So there are going to be 2 x-intercepts. Okay, so somebody online, tell me what to do to find the x-intercepts. We know there are 2 x-intercepts. How do we find them? Okay, the answer is the same as before. To find the x-intercepts, replace y with 0 and solve for x. Okay, so we're going to find the x-intercepts. To find the x-intercepts, replace y with 0 and solve for x. So the reason we replace y with 0 in order to find the x-intercepts is because every x-intercept has a y coordinate that is equal to 0. Okay, so replace y with 0 and solve for x. So here we can divide both sides by 2, since everything is a multiple of, or the coefficients, I mean, and the constant are multiples of 2. 0 divided by 2 is 0. And then 2x squared plus 8x plus 4 divided by 2 is x squared plus 4x plus 2. So we can't solve by factoring, so we'll use the quadratic formula where a is 1, b is 4, and c is 2. So x equals -4 plus and minus the square root of 4 squared minus 4 times 1 times 2, all divided by 2 times 1. So we get -4 plus and minus. Inside the square root, we have 16 minus 8. Again, we saw that before. The square root of 8 is 2 times the square root of 2. So -4 plus and minus 2 times the square root of 2, all divided by 2. So one x-intercept, when we cancel the common factor of 2, one x-intercept is the ordered pair -2 minus the square root of 2, comma 0. The other x-intercept is the ordered pair -2 plus the square root of 2, comma 0. Okay, and the y-intercept, can be found by replacing x with 0, either in the standard form or the vertex form. It doesn't matter. But the standard form is usually easier when you're trying to find the y-intercept. Replace x with 0, we get 4 for the y-coordinate. When we're looking for the y-intercept, the reason that we replace x with 0 is because the y-intercept has an x-coordinate that is equal to 0. Okay, I'll leave the graphing of that for you to do. So you should know that the parabola opens up. The vertex is the lowest point on this parabola. There's the y-intercept and the 2 x-intercepts. Okay, the next one, y equals -2x squared plus 12x minus 16. Let's get this into vertex form. Okay, so we get y equals, we factor -2 out of the first 2 terms. We leave the minus 16 outside. So factor -2 out of the first 2 terms only. And when we do so, we get x squared minus 6x. And then the minus 16 on the outside. Okay, the next step is completing the square step. So now we're just focusing on x squared minus 6x. We want to add 0. The form 0 takes is +9 minus 9. So this +9 was determined by taking 1/2 of -6 and squaring that number. 1/2 of -6 is -3, but when you square -3, you get +9. And then as soon as we add 9, we subtract 9 to maintain balance or equality. Okay, in the next step, we retain the perfect square trinomial, x squared minus 6x plus 9. And we already have a minus 16 on the outside, but together with that, what goes with the minus 16 on the outside? All right, I finally got an answer. Plus 18. So in the previous step, the fourth term in the parentheses is minus 9. But we're going to move that out, but we have to multiply it by negative 2. We're just applying the distributive property of multiplication over subtraction. Negative 2 times negative 9 is positive 18. Okay, the next step is the vertex form. So we have negative 2 times the binomial x minus 3 squared, and minus 16 plus 18 is plus 2. Okay, the vertex. The vertex of the parabola is a point in the xy plane. Every point in the xy plane is associated with an ordered pair, meaning that it has an x coordinate and a y coordinate. So the x and y coordinates of the vertex are positive 3 for x and positive 2 for y. Okay, how many x-intercepts are there? Somebody type in the number of x-intercepts that we have. The choices are 0, 1, or 2. But only one of those can be correct. One and only one. That is not the correct answer. Yeah, there are 2 x-intercepts. How do we know that there are 2 x-intercepts without even graphing? The vertex is above the x-axis, but the leading coefficient of the quadratic function is negative, which means the parabola opens downward. So that means the vertex is the highest point, and if the parabola opens downward, it has to cross the x-axis twice. Okay, so we have a minute or two left. So let's find the x-intercepts. Since every x-intercept has a y-coordinate that's equal to 0, we find the x-intercepts by replacing y with 0 and then solving for x. So 0 equals negative 2x squared plus 12x minus 16. We can get rid of some of the clutter that's in the way if we divide every term on both sides by negative 2. And we'll get 0 equals x squared minus 6x plus 8. And this one factors pretty nicely. The two factors are x minus 2 and x minus 4. So the solutions to that equation are 2 and 4. So the x-intercepts, which are ordered pairs, one x-intercept is the ordered pair 2, 0. The other x-intercept is the ordered pair 4, 0. And let's find the y-intercept while we're at it. Since every y-intercept has an x-coordinate of 0, the way that we find the y-coordinate of the y-intercept is to replace x with 0. So we get negative 16. The ordered pair 0, negative 16 is the y-intercept. Okay, we're out of time for today. Tomorrow we'll be moving on to the next section. And also keep in mind that 1 week from today will be test 4. It will be over chapters 9 and 11.